All right, let's start talking our way through the check your understanding. Why is this a valid probability model? Akeem. The sum of all the probabilities is 1 or 100%. Ben, what do you have? Same thing? Yes. Every probability is between 0 and 1. There's one more thing that I would want to see here. Yes. Yes. It shows all the possible outcomes and their probabilities. So the probabilities add up to 1. All possible outcomes are listed. All probabilities are between 0 and 1. That's why it's a valid probability model. Explain why the events have one child and have two children are mutually exclusive. Before we do that, what does mutually exclusive mean? They both can't happen at the exact same time. Or you could say they can't both happen at the exact same time in the same location, right? So like I can't have one child and also have two children. Like I have one kid, but I can't say I have only one child and then also say I have only two children. Those two events can't happen at the same time. So my answer for this one, you cannot have exactly one child and exactly two children at the same time. The events cannot occur together. Other examples of mutually exclusive events. I cannot spend spring break 2024 in Los Angeles and spend spring break 2024 in New York City. I can't do both at the same time. What's the probability that a randomly selected mother has less than 2 children? 22%. Here's my proper notation, probability. If you just had probability 1 or P1, that would be fine. I went ahead and added the child, but almost always with our probability notation, there's going to be all kinds of abbreviations going on. So P parentheses 1 or P parentheses 1 child. She has 1 child. 0 children is not an option. If it's less than 2, it's 1. I'm not saying that in real life 0 children isn't possible, but in this probability table, we're talking about mothers. So they have at least 1 child. What's the probability that a randomly selected mother has 1 or 2 children? 63. So let's talk about how to write our notation and then how to calculate that. So the probability of 1 child or 2 children. We are going to use our general addition rule. I would take the probability of 1 child plus the probability of 2 children minus, oh, and I apparently can't spell child, chilled, and 2 children. Those are mutually exclusive events. They cannot occur together. So I'm going to take 0.22 plus 0.41 and get 0.63. I'm subtracting 0. Normally, we do have to subtract out the intersection because those people would have been counted twice. One other thing that I want to point out before we go and look at the last part, part E here. In this notation, or, common notation for or, looks like a capital letter U without the stick on it. This is or. Another word for that is union. That's why it looks like a capital letter U. And we have additional notation for that. This one looks like an upside down U with no stick on it. This is and, or it also gets referred to as an intersection. Those are really commonly used notations. Can you write the word or? Yes, you're going to take up less paper if you use the union symbol. You also need to be familiar to be able to recognize them. If you see probability notation written with a union or an intersection, you need to know what that means. Find the probability that a randomly selected mother does not have 4 or more children. Does not have 4 or more children. What did you say? 0.87. So my notation on this, 4 plus children complement. This right here is what I use to indicate not. So that'd be 1 minus the probability that she does have 4 or more children. So we're doing 1 minus 0.13. And we get 0.87. Anytime you see that not, we're looking at the complement. And the way you find the complement is always 1 minus the probability that it is. So far, so good? All right. I have a question for you guys. We're going to do a quick, it's not quite a poll. I'm going to have you guys fill in this two-way table over here. It's over on the door. Please read it carefully. Let me pull this down so you can see it. I want to know whether you guys can taco tongue or evil eyebrow. I'm going to show you pictures for what I mean. So taco tongue. Can you do that? Evil eyebrow. Dr. Evil, you can make one eyebrow go up and not the other. If you can do both, I want you to put a tally mark here in this first box. If you can only do the taco tongue and you can't do the evil eyebrow, you're going to put it over here. Yes, taco tongue, no evil eyebrow. If you can't do either one, you go right here. And if you can only do the evil eyebrow, but you can't do the taco tongue, go right here. If you don't know whether or not you can evil eyebrow, ask a neighbor to tell you. Try to do it and see if you can. Impressive.
All right. Oh, you can do that.
I'm not. All right. I need you guys to come up here and put your tally marks where they belong. I got mine up here. I got 4 markers. Please trade off until everybody's got a mark up there. Both would be the intersection of yes and yes.
Wait, I can't do that.
Thank you.
You can't do that. Just like that.
We got a group of talented people in here today. Thank you. My mom can. I can't. My mom's double jointed. So. All right. Okay, so final tallies. I want you guys to add this on page 9 in your notes packet. We've got 13 people that said they can do both. There is 1 person that can taco tongue but can't evil eyebrow. There is 1 person that can evil eyebrow but cannot taco tongue. And we did not get any tally marks here in the no and no. All right, so let's get our totals here. Make sure that everybody actually answered and only answered once. How many people in the room can taco tongue? Looking at our tally marks, how many people can? 14, so we got all but 1. because I decided to participate today. What is our grand total for no taco tongue? 1. I remember studying that in like, we had to do this in like my high school biology class, and they talked about how it's like dominant and recessive traits. Have you guys done those? Yeah. I want to say that like rolling your tongue is, that's a dominant trait, I believe, but there's definitely the recessive, so if neither of your parents can, you probably can't either. How many total people in the room can evil eyebrow? 14. How many cannot evil eyebrow? 1. Neither can Mrs. Bieshke. How many people are there in here? Don't count. Look up here. How many people participated? 15 total. Grand total goes down here. The total from this, our column, should match the total down here. They should both add up to the same amount. So this guy over here is called a two-way table. And we've worked a little bit with two-way tables. Do you guys remember back in chapter 1 we saw some two-way tables? A little bit. This guy over here is a Venn diagram. It's called a Venn diagram because the person that came up with it, his last name was Venn. I did not know that for the longest time. All right, so a Venn diagram. When we look at a Venn diagram, this gives us a lot of information at a glance, but there's several people that I've worked with over the years that the whole thing just kind of confuses them. Anything inside this circle includes all the people that answered yes to being able to taco tongue. So I would have to add these two together to get all the people that can do the taco tongue. And anything inside this circle over here, these are all the people that said yes, they can evil eyebrow. So again, I'd have to add these two numbers together to get the total number of people that say they can evil eyebrow. So each of these circles is like a row total or a column total. In the middle, we call that our intersection, where my two circles are, surprise, intersecting each other. This includes people that fit in both circles, because they can do both. How many people do we have in our intersection? 14. So I'm going to put 14 here. I know that the total for yes, evil eyebrow was 13. Thank you. There we go. 13 people said they could do both. The grand total for this whole red circle should be how much? 1. So out here are people that yes, evil eyebrow, but they don't fit inside the other circle. So I'm going to put my one lonely person over there. Yes, taco tongue. This has to be everybody that answered yes to taco tongue. We got 13 people that can do both. So over here would be how many people? Just one person that can't. And then it might seem silly, but this blank over here, this is a really important one. This is people that answered no to both of those. They don't fit inside either one of those circles. In this particular class today, we didn't have anybody there, but I'm still going to fill it in, because if you don't fill it in, then I don't know if you just forgot or if there was nobody. If you fill it in and you put a 0, then I know you didn't forget. There was just nobody that met that criteria. So this right here is no to both. They don't fit in any circle. So far, so good? Cool. Let's find some probabilities. So the probability that somebody said yes to taco tongue. 14 out of 15, absolutely correct. Here, let me grab all those numbers again so that I don't have to keep going back and forth and back and forth. And I'm going to erase this for now so that I don't run into that. it didn't grab all my numbers. Okay, time to fill it in again. 13, 1, 1, and 0. There we go. We have 14 out of 15 that can say yes to Taco Tongue. What about no to Taco Tongue? What would my probability be? 1 out of 15. Can anybody tell me another way to write this instead of saying no Taco Tongue? Taco Tongue with a little c. So I'm going to use TT instead of Taco Tongue. You guys okay with that? All right, so probability of Taco Tongue with a little c up there, complement. Yes to evil eyebrow. What is our probability there? 14 out of 15 again. No to evil eyebrow. 1 out of 15. We could also represent that with probability evil eyebrow complement. As long as your abbreviations make sense, it is perfectly appropriate to abbreviate when you're doing probability notation. Yes to Taco Tongue and yes to evil eyebrow. 13 out of 15. Another way to write this one, I can do probability of Taco Tongue. What symbol meant and again? And is my intersection. The and is the overlap. They can do both, so they go in both circles. So that's why it's my intersection. So Taco Tongue and evil eyebrow. What's another way that I could write the one right below that? It's going to have an intersection again. So probability Taco Tongue intersection. How would I do this one? EE, evil eyebrow, complement. What was the probability of people, or the probability that any random person in this room said yes to Taco Tongue, but no to evil eyebrow? 1 out of 15, right? Is that 1 out of 15? Yes, Taco Tongue, no evil eyebrow? Yep. Yes, evil eyebrow, and no Taco Tongue. So probability EE, intersection, TT complement. So yes, evil eyebrow, so I'm looking inside here, but no to Taco Tongue. What do we got for our probability? 1 out of 15. No Taco Tongue and no evil eyebrow. Give me another way to write that. Probability TT complement, intersection, evil eyebrow, complement. How many people said no Taco Tongue and no evil eyebrow? 0 out of 15. You can write it as a fraction, but if it's 0, you could also just write 0. Doing okay so far? All right. Next set down. Suppose we randomly chose a student from class. Find the following probabilities. What's the probability that any random person said yes to evil eyebrow? 14 out of 15. No to evil eyebrow. 1 out of 15. This would be an example of what thing that we talked about on the warm-up and what thing that we talked about yesterday a little bit. These are mutually exclusive events. There was nobody in the room that could go in both of those categories. You had to pick one. You either can or you can't. So what would the probability, here, let's use our notation, probability yes, evil eyebrow, or, here's my union, no evil eyebrow. So evil eyebrow complement. What's the probability that somebody said yes to evil eyebrow or they said no to evil eyebrow? 1. 15 out of 15. My general addition rule would tell me that I had to do the probability of evil eyebrow plus the probability of evil eyebrow complement minus the intersection, the and. So the probability of evil eyebrow and evil eyebrow complement. So when I'm looking at my probabilities, probability of evil eyebrow, you guys told me was 14 out of 15. Plus the probability of evil eyebrow complement, 1 out of 15. Minus the intersection, which we said was 0, because these are mutually exclusive events. If they're mutually exclusive, the intersection is empty. There's nobody that fits in both categories. And that's how we got that 15 out of 15, or 1. What do we call events that have a probability of 1? A certain event. So it is certain that you either can or cannot evil eyebrow. Does that make sense? Suppose that we chose a random student from class, probability that they can taco tongue. 14 out of 15. Yes to evil eyebrow. 14 out of 15. The probability that we have yes to taco tongue or my union, yes to evil eyebrow. Can I just add those together and say that that means it's 28 out of 15? You got to subtract what? The ones that are double counted. So I'd have the probability of taco tongue plus the probability of evil eyebrow minus the people that I counted twice because they were part of both circles. The probability of taco tongue, intersection, and evil eyebrow. Our probability of taco tongue, you told me, was 14 out of 15. Plus evil eyebrow would be another 14 out of 15. Minus what? 13 out of 15. So 14 plus 14, I get 28 minus 13. What's 28 minus 13? So I get 15 out of 15, or 1. Do you think that that would always be a certain event? Is it always guaranteed that somebody either says yes to taco tongue, or they say yes to evil eyebrow, or they say yes to both? Nope, there's some people that can't do either one. In that case, it would not add up to a probability of 100%. If we had anybody that was in the no and no category. These are or are not mutually exclusive events? Not. How do I know? By looking at the work that we did. Yep, there were people in both categories that we had to subtract back out again. Not mutually exclusive events. When I have mutually exclusive events, my intersection, my and, will always be a 0. So if I know ahead of time these are mutually exclusive, I don't actually have to subtract anything off because I'd just be subtracting nothing. If they're not mutually exclusive, you have to be sure to subtract out where you've double counted. This was on the other page, but I want you guys to write it down. The general addition rule. General addition rule, the probability of an or, A or B, is equal to the probability of event A plus the probability of event B minus the probability of their intersection, probability of A and B. What if you didn't know if two events were mutually exclusive, but you knew these three things? If you knew the union and you knew the probabilities of both events, could you determine whether or not they were mutually exclusive? Yeah, you're going to be able to work backwards and find what the intersection would have to be. Let's flip this over. It's about as deep as we're getting for today. Two-way tables and Venn diagrams, very, very connected to each other. You can use a Venn diagram to make a two-way table. You can use a two-way table to make a Venn diagram, or you can make both of those given enough information about the situation. A lot of times, they'll give you, like, what's the probability of two events happening together, the and they'll tell you what the probability of event A is and the probability of event B. So if I know the and I know what it should add up to, I can use that to figure out what A complement or what B complement would be here. So you want to fill in your missing pieces. Sometimes it won't feel like you have enough information, but I promise you I'm not giving you any problems where you don't have enough information to find the probability. General addition rule, we've got our union, we've got our intersection. If the events A and B are mutually exclusive, they can't occur together. So then you would just have A or B is the probability of A plus the probability of B. Proper probability notation is definitely something that's important. Don't just write down the numbers for the probabilities. I want you guys to practice writing proper notation here. If I have notation in my probabilities that is slightly different than yours, but if I read yours, it would mean the same thing as mine, we're totally fine on that. It's not like there's standardization for how you have to abbreviate things. Take about 5 minutes or so, and I want you guys to try to check your understanding at the bottom. A, B, C, D. What does the notation in number 1 mean? Like in plain speak, not in math stats class speak. What is P parentheses O little c where an exponent goes?
Is the probability of someone not pulling over the road?
Somebody, yeah, the probability somebody does not pull the toilet paper over the top, or the probability that they like it like behind or under, right?
Oh, that's the answer.
Yep.
Oh,
Yep. So I saw this funny little meme about this because people are real particular about how they like their toilet paper rolls. I don't really know why it's that big of a deal. But people that prefer it over the roll, there was this little meme. It has the toilet paper roll and coming forward, and this little cartoon says, "Beards are cool." Comes down the front. Mullets are not. Shouldn't be hanging down in the back. Made me laugh. All right, in plain language. Probability of O complement is the probability of choosing a student who does not prefer the toilet paper to pull over the roll. And then it said to find the probability. That would be 46 out of 116. Which you had to do a little bit of addition to find. You had to add up everybody in that no column. Grand total was 116. Why does the probability of O or R not equal the probability of O plus the probability of R? What are they using R to mean here? Replace. Whether or not you replace the toilet paper. I think most of the people in my family go in the not column. Why is the probability of O or R not equal to the probability of O plus the probability of R? Why can't I just add those two probabilities together to get the union? Yes. Because it's ignoring the overlap. We're double counting some people in there. The events pull over the roll and replace when empty are not mutually exclusive. So what is this probability? Probability that somebody prefers the roll over, or the probability that they replace it when it's empty. 94 over 116. We would do 70 over 116 plus 82 over 116 minus the intersection 58 over 116 gives us 94 over 116, or you can write that as the decimal 0.81. Your two-way table should look something like this. I have over in the left-hand circle and replace in the right-hand circle. The overlap should have 58 in it. That was yes to both. 12 people fit in the over circle, but they don't go in the intersection. 24 people go in the replaced circle, but they don't go in the intersection. And 22 answered no to both. Yes. Do you have to write it inside a rectangle? Good question. Yes. Yes. That rectangle is called the universe. And that shows me that I'm containing everything in here. So I've got everybody accounted for. Write the events, does not replace the roll, and prefers toilet paper pulls over the roll in symbolic form, and find the probability. So symbolic notation, that is how I would do my symbolic notation. The probability of R complement and O, or my personal preference would be that you write this as an intersection. If you write the word and instead of an intersection, I'm not going to count it wrong. Personal preference is that you learn how to use the union and intersection notation. What is the probability of that? Does not replace the roll, and they prefer over. 12 out of 116. Nice work. Or 0.103. Anytime you're asked to write probabilities, fractions are perfectly appropriate. Preferences are, when you're doing probabilities, if you're going to write it as a fraction, don't reduce it. I'm not going to count it wrong if you reduce it, but the preference with probability is that these are unreduced fractions. You can always write them as decimals. I would accept percentages, but my preference would be for either decimal or unreduced fraction form. Homework is due tomorrow. It's 3 pages. You should get started on it. We will grade that tomorrow at the beginning of class, and then we will start talking about the last section that we need to cover in Chapter 5. We should finish up all the notes by Monday. Have a good one, guys. I'll see you tomorrow.